In this video, we're going to talk about derivatives of inverse functions. The first thing to remember about inverse functions from Algebra 2 and from pre-calc, we switch x and y. Switch x and y. And that the inverse undoes what's already done. So you can see we have a function here, f of x equals x squared plus 3. And on that function is the point 1, 4. Which means, of course, that f of 1 squared plus 3 equals 4. We also have a second function down here, g of x equals the square root of x minus 3. And it has the point 4, 1, switch x and y. And if we take g of 4, it gives us the square root of 4 minus 3, which is 1. So you can see how they undo each other. F and g are inverse functions. And if I start with 1 and put 1 into f, when I put the answer into g, it gets me right back to where I started. Okay. We also remember about inverse functions that their graphs are reflections over the y equals x line. So you can see how it's a reflection. They're the same graph, just reflected over the y equals x line. Okay, so you can see that we've drawn in the tangent line that's tangent to the point 1, 4 to f of x, and the line that's tangent to the point 4, 1 on g of x. Well, I can take the derivative of both these functions. F prime is just 2x, which means f prime of 1 would just be 2. And now you might speculate as what you think the slope here is. We switch x and y, but we can calculate g prime. Let's do that over here. Of course, it's a trivial chain rule because the derivative of the inside is 1. So it's 1 over 2 root x minus 3. And then if we take g prime of 4, the point that's on that curve, 1 over 2 and the square root of 4 minus 3, which of course is 1. So it's 1/2. So g prime of 4 is 1/2. Those slopes are reciprocals. Would certainly make sense if we are switching x and y, because if we switch x and y, then when we think about our slope formula, what was y2 minus y1 on the top is now x2 minus x1 on the bottom. Another thing we have to know about when we're doing derivatives of inverse functions, we have a point right here on f of x that has a horizontal tangent line. Right, that's 0. So f prime of 0 is 0. So the reciprocal of 0, 1 over 0, we can't do that. We can't take the reciprocal of 0. What it means is that the point that corresponds to that point on g we can't take the derivative there. Well, that point is this point right over here. Point the arrow here. So at this point we'd actually have a vertical tangent. So we can't differentiate at g of 3. So there's no g prime of 3 does not exist. We can't take the derivative there. It has a vertical asymptote or a vertical tangent line, which of course the slope is undefined. So let's talk about how we can find derivatives of inverse functions. Using what we just talked about, we're going to talk about how we can find derivatives of inverse functions. So let's just take up here. We know that f of g of x is going to equal x. That's the property of inverse functions, that when you plug one into the other one, you always get x, no matter what order. I also could have done g of f of x and it would be the same thing. So if I take the derivative of that using the chain rule, I would have f prime of g of x times g prime of x, derivative of the outside times the derivative of the inside, equals, and the derivative of x is just 1. Now if I solve that for g prime of x is 1 divided by f prime of g of x. That's where the formula for that we're going to use for the derivative of an inverse function comes from. Okay? So we say this: if f is differentiable, okay, if f is differentiable and g of x is f inverse of x, then g prime of x equals 1 over f prime of g of x. Another way of writing the same thing is a little clumsy, so we don't usually write it this way. We could write it with the inverse notation. We write this: f inverse prime of x. Again, like I said, it's a little tedious to write it, a little bit clumsy. Equals 1 over f prime of f inverse of x. Okay. Or there's another way, which I like. I think it helps us clarify our thinking, and that's this: if f of a equals b, then g prime of b equals 1 over f prime of a. Alright, well, let's look at an example here of how we would do this. Okay. Alright, so it says find the derivative of the inverse to f of x equals 2x cubed plus x squared minus 1. Now the reason we have this formula for finding derivatives of inverses is that finding the derivative of this function, this cubic function, would be extremely difficult and very time consuming if you can do it at all. You know, and sometimes we run into functions like that it's really hard to take the inverse of. So in this case we don't need to take the inverse of the function. It's not needed, so we're not going to do that. Now, we know then, let's say that g of x equals f inverse of x. And so that g prime of x then equals that 1 over f prime of g of x. So g prime of 2 would equal 1 over f prime of g of 2. Okay. Now, you might say, well, now I just have to find g of 2 and plug it into f prime, because I can take f prime, which I know would be 6x squared plus 2x. However, they don't give me a formula for g of 2. They give me a formula for f, but they do not give me a formula for g of 2. So somehow I've got to find out what the value of g of 2 is, and then I can plug that into f prime and I can get my answer. Well, we can use the information they gave us because we know that f and g are inverses. Okay? So in other words, if I can find if the point 2 g of 2 is on g of x, then the point g of 2, if we switch x and y, is on f of x. So in other words, if I can, when I plug something into f and I get out 2, that's going to tell me what g of 2 is. That's going to tell me, that would be my x value. That would be my x value. So in other words, I'm going to take this function f of x and I'm going to set it equal to 2. Now sometimes you can take these and you can solve them with, you know, quadratics, but in this case we're going to have to take and just do the quickest way possible, which is just to graph this. Okay, which is just to graph this, and this is plus x squared, 1x squared minus 1. Okay? And so that's what we're going to do, is we're going to use our graphing calculator to do this. Okay, so I'm going to go to y equals, and I'm going to clear things out here. I'm going to plug in 2. I plug in each. Into y1 I plug this side, and into y2 I plug the other side, 2x to the third plus x squared minus 1, and I graph those. So I need to change my window. zoom 6 for zoom for the standard window. There it is. There's y equals 2, and there's the function. You can see they intersect here. They intersect at about 1, it looks like. Well, let's use the calculator to find out for sure if it's exactly 1. Second trace, we want number 5 for intersect. First curve, second curve, get them close to each other, close to that intersection, and hit enter, and sure enough the intersection is 1, 2. So in other words, we go back to here, then when x equals 1, then f of x equals 2. So the point 1, 2, which means is on f of x, which means 2, 1 is on g of x. So g of 2 is 1. Now I can plug that in here. Okay. F prime of 1 equals 6 plus 2, which is 8. So we come down here and we be 1 over f prime of 1, which is 1 over 8. That is the derivative at x equals 2. Now let's do another example. Very similar thing, now a different function. Okay. So we want to find the derivative of the inverse. So again, we're going to say g of x equals f inverse of x. So g prime is 1 over f prime times g of x, and then the derivative here, f prime, of course, would be e to the x plus 1 over x, and we want to do it at x equals 4. So we want g prime of 4, which is 1 over f prime of g of 4. So again, we have to do 4 equals e to the x plus natural log of x, and we have to solve that. We're going to do it the same way. We're going to graph it. So I'm going to go back to y equals. I'm going to plug in 4, and then I'm going to plug in e to the x plus the natural log of x. Going to graph it, and it again looks very close to 1. I don't think it's exactly 1 this time, but let's see. Second trace, number 5, first curve, second curve. If you hit enter, it won't let you because there's no y value there, so you have to move a little bit so that the y value shows up. Hit enter, and then guess, just hit enter again, and we get 1.315. So x is approximately 1.315. Now, so then we want to take f prime of 1.315, which is e to the 1.315 plus 1 divided by 1.315. And so we can calculate that with our calculator as well. So we have e to the 1.315 plus 1 divided by 1.315, and we get f prime of 1.315 equals 4.485. And then so this of course is 1 over f prime of 1.315, which is 1 over 4.485. You can leave it that way. You can also divide it. Okay. Get a separate decimal from there. Okay. Third example. The function f is differentiable for all real numbers. The function g is the inverse of x. The table below gives values of f prime, and not g. So write the equation of the line tangent to y equals g of x at x equals 4. Now, so we want to write the equation of the tangent line, so of course we're going to write it y equals y1 plus m times x minus x1. and it says g is the inverse of x. So g prime of x then is going to equal that 1 over f prime of g of x. So g prime of 4 is going to equal 1 over f prime of g of 4. Okay. So we need g of 4 again, but this time we don't have an equation that we can use to help us find 4. However, we know that g is the inverse of x. So if we talk about switch x and y, since this is x and f of x, if we switch x and y, these would become x, and this would be f inverse of x, which we know is g of x. So g of 4 then would be 3. If I take this column right here, I look, there's 4, and I look across to g of x is 3. So I just do, this would be 1 over f prime of 3, and f prime of 3 is negative 2, so it'll be 1 over negative 2. Very similar down here. It's g prime of 3, it's the same function, we'll write the equation of the tangent line in a minute, equals 1 over f prime of g of 3. G of 3 is 1, so 1 over f prime of 1, which is 1 over 5. And so if we write the equation of the tangent line, we know that the point 4, 3 is on this one, and the slope is negative 1/2. So it'll be y equals 3 plus negative 1/2 times x minus 4. Okay. And then here, it would be y equals the point 3, 1 is on the curve. So y equals 1 plus 1/5 times x minus 3. Alright. Those are our answers. Those are the equations to our tangent lines there. Alright. Find the derivative to the inverse of f of x equals sine of x. Well, first of all, let's do f prime, which we know to be cosine. And we want to do it at x equals pi. Okay. We know that the sine of pi is 0. Sine of pi is 0. Now, so g prime equals f inverse of x. And so g prime, or g equals f inverse. So g prime is then 1 over f prime of g of x. So it's 1 over f prime of g of pi. Alright. So